Hello everyone, welcome to Maths Bridge. We train and learn. We are going to start C++ programming. Let's get started. In today's agenda, our learning goal would be we shall look at a C++ overview, IDEs. IDE mean Integrated Development Environment. Look at various C++ supported IDEs. What is the need of IDE? Translation of C++ program, code compilation. Look at Hello World sample program. Few concepts in and around of program along with like an IDE. We shall see C++ advantages, few real-time applications. I'm sure we all knew C++ is a middle-level programming language. C++ was developed by Bjorn Sjöström at AT&T Bell Labs in 1979. C++ is an extension to the C language. It includes a combination of both high-level language features and a low-level language features. C++ supports a procedural and generic programming. C++ is compiled and case sensitive. C++ supports OOPs in concepts like inheritance, polymorphism, encapsulation, abstraction. It runs in many platforms like Windows, Linux, Unix, macOS. It provides a lot of inbuilt functions and also supports a dynamic memory allocations. Like a C, C++ also allows you to play with memory using pointers. It gives a software developer a high level of control over systems, resources, and memory. When you would want to write a software program, the first thing that comes in your mind, where would I need to write a software program? Is it on a piece of paper or a text editor in your computer? Isn't it? Right? Let's say you wrote a program. The next thing comes in mind, how do I compile the code? How do I generate an output file, a executable file? Where do I run them? How do I see an output? Is there any tools that are available to do this job for us? Isn't it? Right? The answer would be yes, we have IDEs. IDE means Integrated Development Environment. There are many IDEs available for the C++ program. So few of them captured here. You can Google them for answering your questions better. We have the Visual Studio, Eclipse, CodeLight, Atom, Turbo C++, KDevelop, Arduino IDE, Borland C++, Dev C++, and many more. A IDE is a software application that helps programmers efficiently can develop a software code. It helps developers in software editing, compiling the software, testing the software program, and debugging if any compilation errors you see in while writing a program, and packing them for easy to use. So it is advised software developers to use IDEs to make their life easier. Apart from all the IDEs which we see earlier, I downloaded Dev C++ IDE and then I installed in my computer. Upon launching the application, this is how I would see my Dev C++ integrated development environment. It is kind of ready for me to actually start writing my sample programs. You could also try. Wow, what a wonderful experience using IDE. I created a project. I created a sample C++ programs and I added to my project. And then you could see it easily, right? And then I started modifying the code based out of my need using my text editor. Once I feel I wrote the code, if at all during the compilation time, if I am getting any errors, then obviously I started fixing them, right? So syntactically, I can see what could be the my program errors, and I can start fixing them. Good thing is this IDE is also suggesting if at all I need some kind of help, I can compile the code, I can test the code that I wrote, and then in order to fix the problem, I can debug the code using that IDE. What an experience. I started experiencing it, and then why would you are waiting for? Let's get started, and then started writing a code using your own interested IDEs and they feel the same. Why are IDEs important? IDEs are helpful for code editing, syntax, code suggestions, refactoring, compilation, testing, and debugging. Let's look at one by one. Code editing. Programming languages have rules for how statements must be structured. These IDEs contains many intelligent features for automatically writing and editing source code. An IDE can format the written text by automatically making some words bold, italic, and some using different font colors and things like that. These visual clues make the source code more readable and gives instant feedback about accidental syntax errors. IDE makes suggestions to complete a code statements when the developer begins typing source code. Code refactoring is a process of restructuring the source code to make it more efficient and readable without changing its core functionality. Compilation. An IDE compiles or converts the code into a simplified language that the operating system can understand. IDE allows developers to automate unit tests locally before the software is integrated with other developers' code or more complex integrated tests to run. Debugging is the process of fixing any errors or the bugs that the testing reveals. So IDE is so important for a developer's job make easier. Let's look at my first C++ sample program known as Hello World program. You could see here I have a project created and then I have added my source file, and then I could see in the text editor what is my sample program would be. I'm trying to print only hello world on the console. But if you look at each line by line, the line number 1, 2 and 3 are the including header files. 1, 2, 3 lines are denoted as a header files, which are preprocessor directives. We can talk more about preprocessor later sections. If you can notice, line number 4, 6, 8 and 12 denotes a blank line. As usual, C++ ignores white spaces, so you don't need to think about it. You can keep as many as white spaces as you needed. Look at now line number 5, using namespace std. The header using namespace std tells the compiler to use names for objects, variables from standard libraries. It is most frequently used, namespace for the C++ programs. Now let's look at line number 7, main. The function that always appears in C++ program is int main. The code written inside the curly brackets will be executed. These are also known as executable statements. Here line number 9, cout, is an object used together with insertion operation is to redirecting the string onto console to print the text, right? The return 0 is a statement, the last statement inside the main function which returns 0. And then line number 13, a closing curly bracket indicates end of the main function. These are the few takeaways that you need to understand, to write your programs. In continuous with earlier discussion, when your sample program is ready, what you have to do, you have to compile the source program. In IDE, we have a button to compile the source code. Let's assume that you compile the code. What you could see as a compilation output, how many files that are there in the program, that you could see. And then, if you look at here, compiling a single file, because the compiler recognizes how many files that are there in your project. Let's see, it started compiling. What is the compiler that is using? G++ compiler is what we are using in Dev C++, which will compile your source program. So I don't want to get into the details here, but let's say you compile everything. What would be the compilation output? If you have any errors, it is going to list it here, how many errors you have, how many warnings you have, and then what would be the final output size, and then how long it takes to compile the total source code. So upon successful compilation of the program, it generates a exe which you can run on hardware. Right? So once after compilation, executed the compiled program, then it produces an output like an hello world on the console. Is it a nice thing to see? So that's why IDEs is very helpful for us to write programs easier, make the modifications as it facilitating us. You can compile, you can test, you can see the output. Since you have seen how single file compilation takes place within the project using an IDE, now let's add a few more. I have 3 source files here: main.cpp, fun1.cpp, fun2.cpp. If you look at what is there within each source file, in main.cpp, I am printing a text, and also I am calling 2 methods which are not defined within the main.cpp. So probably those definitions can be seen in other source files. Source files means ACPP files. Fun1.cpp, where I have a definition of fun method, and then I have text within it to print the text on the console. Similarly, if you look at a fun2.cpp, where I have fun2 method definition, and then I have a simple text to display on the console. Isn't it right? I have 3 source files. When I compile the project, what it generates is 3 objective files generated corresponding to 3 source files. You can easily see them. Upon objective files, I can see final executable file. When I run this executable file, it produces output like hello world, and then fun1 statement and fun2 statement. The order in which I'm calling the methods, right? The method having associated in a cout statement, which you can see an output. Isn't it right? The takeaways are objective files the compiler generates for each source file, and then link them all together into a single exe file which runs on the hardware platform. Let's look at here in your computer file system. What are the files that I am seeing here on the console would be seen on your computer system. You go to the folder, source folder, where you have the files. So what are the files that you added in the project can be seen here: fun1.cpp, fun2.cpp, main.cpp, and then there's the project files. And the second thing is, when you compile the code, it generates object files, right? You can also see them here, object files within the object file specific folder. And then you are also seeing executable, right? Exe. That exe you can see on the file system too, right? This is good learning. Whatever you see on your project space can also be seen in file system. Should be right. Nothing new, but just recapping of what you see in IDE versus like what you could also see them in the file system. That's only the learning that I'm trying to reiterate in this slide. Let's take a look at how translation of programming language takes place in the C++ world. We know that we have a high level language, assembly language, machine language, hardware, right? So the key important points here is we have a preprocessor stage, we have a compiler stage, we have a assembler stage, we have the linker, we have a loader. Let's see what each one does in the translation. Preprocessor takes all the C++ files, all header files, and combine them together to generate a complete C++ source programs, which will be input to the compiler. What compiler does? Compiler takes C++ source programs and it translates them into intermediate programming languages, is known as a assembly language. So now we have a intermediate programming files. So what assembler will do? Assembler takes them and it translates them into object files. In the previous example, you could see there are 3 source files and the 3 object files. So 3 object files are getting generated corresponding to 3 source files which we have in the project. Having said that, what linker will do? Linker takes those object files and library code and link them to generate a complete object code. At this point of time, you will have a single file which is known as a exe file, executable file. Now we have exe file. What you would do? You need a loader to load the exe file onto hardware memory and then trigger the execution. Upon execution of the file on the hardware, what it does, it generates an output. It generates an output, isn't it, right? The output is what you see on the console from the previous example. A preprocessor is a program that processes input data to produce the output used as an input with another program. Just reiterating. I hope you are clear. The takeaways: preprocessor, compiler, assembler, linker, loader, hardware files. Source code compilation. We have seen compilation is one of the conversion process while translating programming languages from source to executable file, isn't it? What we learned is compilation takes the source file and generate into intermediate programming languages. But what exactly it does for doing that? So what it does is it does a logical analysis, syntax analysis, semantics analysis, intermediate code generation, then after optimizing the code, generating the final code. The final code would be the intermediate programming is what you said before. Along with this, it also does 2 more things: building a source table with all these symbols, you can call it as a symbol tables, and error handlers. It captures all the errors, okay, within your source files. What are the advantages of C++? C++ is case sensitive and compiled. The compile time is faster. Similarly, the execution time is also faster. C++ uses pointers. C++ very close to hardware like a C. C++ has rich library support. C++ supports object-oriented programming and so on. C++ supports object-oriented programming. In an object-oriented program, we studied objects, classes, data abstraction, encapsulation, inheritance, polymorphism, dynamic binding, message passing, isn't it? Object-oriented program is a programming paradigm or pattern of programming based on the concept of objects. The solution to the programming problem is modeled as a collection of collaborative objects. Objects can contain data and code. Data in the form of attributes, code in the form of methods or functions. A common feature of the object is that the methods are attached to the data and can access and modify the object's data fields. It is most suitable for managing large and complex problems. What it indicates, C++ programming can be used in wide variety of application space. Let's look at C++ real-time applications. C++ is used in embedded systems, developing operating systems, designing compilers, developing games, DBMS, database management systems, GUI-based desktop applications, graphics, and browsers are mostly used in C++ for rendering purpose because C++ is faster, both in compilation time and execution time. And there are many more.
Thanks for watching. Please like, share, subscribe, click on the bell icon and please leave the comment. Happy learning. Thank you. Stay tuned to the upcoming sessions.